In this video, we aim to demonstrate how automatic routing can be utilized in plant simulation. Initially, we can apply automatic routing to every mobile unit. However, in the following example, we will focus on parts. To illustrate this, we have already prepared an example where we will showcase various examples of how to use automatic routing. In the first example, we will concentrate on the upper part of the model. Here we have built a production line consisting of conveyors and stations. You can simply rebuild this model by using the standard objects. Additionally, we have duplicated two parts and renamed them to Part A and Part B. Furthermore, we altered their appearance to visually distinguish them. These parts are created from the sources. We have then inserted checkboxes which are used to control the number of produced parts from the sources. Depending on our showcase, we will set the number of produced parts by the corresponding source to 0. If you want to use these checkboxes, you can type checkbox in the online help and learn how to use them. We can then open the control of the checkbox to have a look at it. Here we can see that we set the amount of produced parts to 1000 if the checkbox is checked, and to 0 if not. Moreover, we have modified the sources so that the parts are produced according to a table, which we open now. In this table, we can observe the production order of the parts. The rationale behind this is to create an unequally distributed order of the two parts. Additionally, we have created an entrance control at each source. In this control, we assign destinations to the parts. We can see that depending on the name, we assign either station A or B as the destination. As we can see, station A and B are in the upper part of our model. We have not activated automatic routing on the parts yet and start our simulation. You will observe that the parts are distributed to the successors of the first conveyor according to its exit strategy, which is set to cyclic by default. When we pause the simulation and hover over the parts, we can see their destination in the tooltip. As you can see, it depends on the name of the part. Either station A or B is assigned. However, the parts on the middle and lower conveyor can't reach station A or B. So, even though we have set the destination to the stations in the upper part of the model, the parts will be distributed according to the exit strategy of the objects regardless of their destination. Now, we want to change this and activate automatic routing for both parts. Keep in mind that now the fastest route will be calculated. However, this does not need to be the shortest one. Then we let the simulation run again. We now observe that the parts automatically follow the route leading to their destination. However, two behaviors become apparent. At the first junction, the parts no longer use the upper conveyor, as this route is not the fastest one. Additionally, we can observe that when there are two successors which are equally fast, the parts are distributed according to the exit strategy of the preceding conveyor. In our AGVs video, we learned that hovering over the AGV reveals its route. Let's restart the simulation and hover over the parts. In the tooltip, we notice a junction. This indicates that there is no deterministic route, as the part can't know to which successor it will be distributed by the conveyor. Consequently, 3 dots are displayed, signifying an undetermined remaining route. As we continue the simulation and wait for the parts to pass the junction, we'll observe the remaining route displayed in the tooltip. We can additionally observe that the route where the station is located is avoided by the parts. The reason for this is that if there is a possible route that does not include passing through a station, the parts will choose that route. If you intend for the parts to follow a route that includes a station, you need to specify that explicitly. This is to prevent unintentional processing by a station. To direct the parts to follow a route where the station is located, we can make use of the route weighting attribute. To do so, we open the Routing tab of Part A. Here we can utilize the route weighting attribute. We will designate attribute A as the name of our route weighting attribute and click on OK. We can now create an attribute with the same name at the station where we want to have the parts process. So we switch to the station and open the User-Defined tab. Here we then create a new attribute of type time and assign 0 seconds to it. The route weighting attribute can be used to decide whether the part should be processed by the station, and additionally enables us to create part-specific routings. By setting the attribute to 0, the route via the station is faster in this example, which means that the part takes the route via the station and is processed. However, it's important to note that this does not change the actual processing time of the station. Next, we let the simulation run. As you can see, now the blue parts will take the route containing the station. We can further utilize this attribute to explicitly prevent parts from moving on certain objects. For example, we could use the attribute to prevent the parts from using the lower conveyor. To do so, we open the dialog of the conveyor. Then, we switch to the User-Defined tab. Here too, we create an attribute that we name after the route weighting attribute from Part A. For length-oriented objects, we can either use the data type real or the data type time. If we use the data type real, the attribute will then be used as a factor for the time the part needs to move through the object. You could also use the data type time, which will be then considered instead of the conveyor speed and length. We opt for the data type real and set the value to -1. The value -1 will prevent the parts from taking the route containing this object. Now we can start the simulation again. We now observe that none of the blue parts take the lower conveyor, and the green parts are distributed according to the exit strategy. Now we will move to the middle part of our shop floor. The middle part consists of conveyors, converters, 2 stations and sensors. First, we will have a look into the entrance control of the second source. Here we can see that data list A or B is assigned to the parts as their destination. Instead of a single destination, we can also assign a list of destinations, which are then approached one after the other in the order of the list. The parts assigned with data list A will have 2 destinations. The first one will be Station 1, and the second one will be Station 2. The parts which have assigned data list B will only have Station 2 as their destination. As the list only contains one destination, we could also use this entry directly as a destination. However, we will add more destinations later on. You might be wondering now how the parts will reach the station when the stations aren't even connected to the conveyors. To illustrate this, we need to zoom into the model, and we will see that sensors have been placed in front of the stations that we are going to open. In the dialog, we can now see that some settings are adjusted. We can see that the sensor is only activated when the part which arrives at the sensor has a destination which matches the destination entered in the sensor. This makes the destination available for automatic routing. In the controls, we just halt the parts for a second and let their movement continue again. In reality, you could move the parts to the station to process them. We start the simulation and pause it again. Now all blue parts will have station 1 and 2 as their destination, and the green parts will only have station 2 as their destination. We can hover over the parts to display the tooltip. Here, we can then see the route to their next destination. However, only the next destination and the route to it will be shown. So, for the blue parts, we will only see the route to station 1. After they leave station 1, we will see the route to station 2. As you can see, the blue parts will automatically find a route to station 2 after leaving station 1, whereas the green parts will only move to station 1 and then to the drain. After the parts have reached their destinations, the converter, which has default settings, will move them to the default exit, which leads to the drain. Now, let's assume that we want the green parts to also move to station 1 and 2, and additionally want to model that they need to undergo a rework at station 2, and therefore have to move there twice. We can simply implement this by opening the data list and entering station 1 in the first row and station 2 in the second and third rows. If we now start the simulation, we will see that the green parts move to station 2 two times. In the Routing tab of the part, we can additionally see the Reset Destination when at Destination checkbox. This checkbox basically resets the destination attribute of the part when the destination is reached. If you deactivate the checkbox, the parts would be in a loop, so the destination would not be reset, and they simply would follow the destinations in the data list endlessly. To showcase this, we let the simulation commence until the blue parts are leaving station 2. If we now hover over a part which has left station 2, we will see that it has no destination. This basically means that the parts follow the exit strategy of the objects from now on. If we would have checked the checkbox, then the destination would be set to the data list again, and the parts would follow the destinations endlessly. We will now showcase what would happen if we extend our model and add 2 routes where we have a station involved. If we let our simulation continue, we will see that the exit strategy of the conveyor is applied, and the parts will be distributed according to the exit strategy of the preceding conveyor. This results in some of the parts being processed by this station again. The reason for this is that even though automatic routing is activated, the part has no destination, and subsequently the exit strategy of the conveyor is applied. To avoid this, you can additionally add the drain into the data list as a destination. If you now start the simulation, the parts won't take the route including the station. If you want to look in the destination list to see which destination the part is moving to, you can also do this easily. To demonstrate this, let's restart our simulation and then stop it. We can now open the F8 dialog and search for the destination attribute. Here we will see that it is set to the data list, which does not tell us to which specific destination the part is moving. However, we also have an attribute called Destination List Row, which is used to examine the destination in a data list. So, we can use this index for lookup in the data list, where we will see the current destination. For the third part of the video, we now activate the checkbox for the third source. We then open the entrance control of it. Here we can see that depending on the part name, we assign station 3 or 4 to the parts as their destination. As we can see, we need to request a worker to be able to move the parts along their route. So we have inserted workplaces. At the conveyor leading to the first workplace, we have then activated a transport importer. With this, a worker is requested to move the parts to the next object on their route. As you can see, a worker is requested, and the parts are moved to the corresponding conveyor. As we can also observe, the parts are picked and placed by a robot as long as it is connected with connectors to the conveyors. Additionally, objects such as the buffer on the route to the destination are handled by automatic routing as well. You might ask yourself what happens if the part deviates from its route. To showcase this, we deactivate the third source and activate the second source. Now the parts will move to the middle part of the model again. We will now create an exit control on the conveyor. We have already created code which we will paste in the method. In this method, we essentially move the second produced part of each type to a successor which is not along their route. However, since automatic routing is activated, the parts will compute a new route to the destination, and if it is possible, they will follow this new route. All other parts are transferred using move without parameters, taking the previously calculated route into account. To showcase this, we start the simulation and stop it immediately. Here, we can now hover over the second blue part. As we can see, the route is computed. Then we let the simulation continue again. As soon as the part is on the new object, we can hover over it again. As you can see, the part has computed a new route to the station. So we let the simulation continue, and we'll see that the parts will find their way to the destinations. So far, we have only shown automatic routing for parts. The same rules that we have shown also apply to the container. These rules apply to the AGV as well, but there are two exceptions. The first one is that when the successor tracks are of same length, the AGVs will be moved to always the same track, which was not the case for the parts. Secondly, AGVs will never take routes which contain stations, even when a waiting attribute is used. With this, our video on automatic routing is concluded.